All right, welcome back to our math lesson today. We are still working on patterns. Today we're going to amp it up a notch, okay? Today is when we add kind of the fourth grade layer to this, but you don't need to be perfect at it yet, okay? As you get older, you're going to keep working on this. And if you notice at the top, mine's cut off, but we're using patterns and equations. So before we even get into this, what is an equation? We've worked with them this year. Angie?
An equation is like a problem with numbers that can solve another number, but it's bigger.
Okay, so let me give you an example. If I had p times 5 equals 40, can we solve what p is? Yeah. Angie, do you know? P has to be 8, right? If p equals 8, that sentence is true. Both sides will balance.
So if it was like on a math, like on our homework, we'd have to see how we got that answer, and I wouldn't know how to do that.
Well, we're going to keep working on it, okay? So we are going to work on equations. We're going to work on how to write them. We're going to work on how to read them and solve them. So all of the above. Hayden?
You could have said 5 divided by 40. Well, 40 divided by 5.
Right. That would be switching it all around, right? Thinking about it a different way. Okay. So stick with me today. It should seem maybe a little hard, maybe not to all of you, but that's okay. It's new material. All right. Up at the top. Does somebody want to read this long problem about Kyle and Camille? Josiah, nice and loud.
Kyle uses pattern blocks to make a different pattern than Camille. He has one triangle followed by 4 squares, repeated vertically. The multiplication equation S 4 times T describes the relationship between the number of squares. Kyle needs 4 T triangles. How many squares does Kyle need if he uses 5 triangles, 6 triangles, 7 triangles?
Okay. So that's a lot of words, and that overwhelms me always. Okay. I don't like reading huge word problems. So we go through and find our important stuff, and then we're going to look at the picture. So, the important stuff in our problem, pencils ready. He has one triangle followed by 4 squares, and it repeats. Well, I'm going to try to figure that out here. So we've got one triangle, 4 squares. If it helps you to trace, it helps me to trace, to really think about it. And then it repeats. One triangle, 4 squares. And then it would repeat again. One triangle, 4 squares. So here's the first row of his pattern, the second row, the third row. Could we continue making more rows of that pattern?
Yes.
Yeah, just one triangle, 3 squares. 4 squares, excuse me. All right, now they gave us a multiplication equation that we could use, and it is S. What does the S stand for? Abby? The what?
Like the answer.
No, we got to read the problem. What does the S stand for, Angie?
Squares.
Squares. So the squares amount will equal 4 times T. All right, well, what's my T? Hayden?
Triangle.
Triangles. All right, hold on. We are not quite to questions yet. I'm still right in the middle of an explanation. So that was all given to us in the problem. I haven't come up with anything. I haven't made sense of anything. I just really copied out of the problem. And I've told you this all year. Why does it help my brain and maybe your brain get the stuff out of the huge word problem and write it to the side? Why does it help? Maybe I'm the only one it does help, but I don't think that's true. Hayden?
It'll maybe make more sense when you write it out yourself.
Yeah. When I read a huge math problem in a huge paragraph, my brain just kind of, it does not like it. So my best advice to you, pull out the equation and write it down and make sense of it. Well, it told us S is for squares and T is for triangles. All right. Last part. How many squares does Kyle need if he uses 5 triangles, 6 triangles, or 7 triangles? We can figure this out. One way we could do it, we could keep drawing our pattern over and over, but you guys know that can take forever. Because what if I asked for the 90th row? We don't want to draw that much. So we need to learn a trick. So here's another way to look at it. We could make a table, which I like the table better than the picture. It's a little bit easier. So we put the number of triangles down this side, and the number of squares go down this side. So I do want everyone to write this for me. S equals 4 times t. Right down here by your table. So we know that however many triangles we have, we multiply it by 4 and it will tell me how many squares I have. Let's see if that works. Up here I have one triangle. So if I said 1 for my t, 1 times 4 equals 4. When I have one triangle, do I have 4 squares? Yep, it works. What about 2? If I filled in 2 triangles, so I have 2 rows, 2 times 4 would be what? Angie? 8. If I have 2 rows of my pattern, do I have 8 squares total? I sure do. I could fill this t in for any number in the world, and it would tell me how many squares I would have.
3.
Let's try 3, and we'll see if we're right. All right, 4 times 3 is 12. Please don't blurt. Does that make sense up there? If I have 3 triangles, do I also have 12 squares in my patterns? Yeah. So, all right, 3 triangles. 1, 2, 3. Are there 12 squares when I use 3 triangles? You just have to count them. It's really all it is. If I have 3 triangles worth of my pattern, I have to have 4 squares with every triangle. 4 times 3 is 12. So all we're doing today is thinking about how I can use my variable, that's what we call the numbers or letters we don't know, and fill in to find different amounts. So now let's fill out the rest of our table while we're at it. If I have 4 triangles, so I can fill in a 4 here, 4 times 4 would be 16, which is what they got. All right, let's try to solve for 5, 6, and 7. And if you need to rewrite your equation, you can, or you could just erase that number. So instead of having 4 triangles now, we have 5 triangles. So the number of triangles t is 5. I fill in my t with a 5, and then I can solve for my squares. So if I have 5 triangles, how many squares do I have? Noah? 20. Fill it in on your table. All right, now we're thinking if I have 6 triangles, my t is a 6, how many squares would I have? Emma?
24.
Okay. And last but not least, if my t for triangles is 7, how many squares would I have? Cadence. 28. So, I see that we've got a pattern going on. We could probably keep skip counting. But would this be helpful if I said, how many squares would I have if I had 74 triangles? Could we solve it? How would we do it? All I'm saying is my number of triangles, I'm going to go down a long ways. It's 74 triangles, and I want to know how many squares I have. Cadence, what would I do?
24 times 4.
That's it. Okay, we don't change it at all. Whatever number of triangles we have, we fill in for t, which this time it's 74. And then I could do turtle head to solve that. So, this is an equation, and this is how we're going to start working on patterns so that you wouldn't have to draw that pattern 74 times, because that would take too long. Liam.
I figured out a pattern. So like the first triangle is like 1. The second triangle is 6. The third triangle is I think 11, and I think it will like keep going like the last number will be 6, and like the last number will be 1.
Oh, like you're looking at the number patterns. You can always find some of those too, right? How the digits look in your numbers. All right, so let's go ahead and flip to the next page. And I usually get ahead of myself before the next page, but now it should be easy. Let me get it erased. Okay. So this part should seem easy to you. We just walked all the way through the first page. So we're still looking at the same equation. I'm going to put a box around it so it's larger. And actually up here, I'm just going to write it really big so everyone can see it. S equals 4 times t. Number 15. What does the S stand for? It stands for something. Dylan? Squares. So for 15, the first part we need to write squares. Make sure you are busy writing this with me at the same time I do. That's how you'll learn the most. Cadence, what's the T stand for?
So I got that, but I got 74 triangles, which equals 296.
All right, so that would have been the number if we had how many? 74 triangles?
Mm-hmm.
Okay. No, what's the T?
Triangles.
Triangles. They told us that in our problem. All right, now they're saying, what does 4 times T mean? What does that mean? Think about it from the previous page. You guys probably know. Hayden?
In a way that they call it a triangle because tri, I think, means like 3.
It does.
And then angles, because it has angles.
So 3-angled shape. You got it. Dylan, what does 4 times T mean?
4 times triangle.
So it means for every triangle, I multiply by 4. That's all that means. For every triangle, I multiply by 4. Or we can put times 4. How about that? We don't have a lot of room. All right, number 17. Look at model it. Describe the number of squares as a multiple of the number of triangles. Well, what's a multiple first? What's a multiple? Emma?
How many times that number could go into?
So like skip counting, right? So multiples of 5 would be 5, 10, 15, 20. Just skip counting on. So Josiah, what are you thinking about that?
It's basically multiples of 4 on each number of squares.
It is. And if we looked at that chart before, mine's gone now, but it said on your square side, 4, 8, 12, 16, 20. We just kind of kept going multiples of 4. So describe the number of squares as a multiple of the number of triangles. The squares are multiples of 4. Because we are chunking them in groups of 4, every triangle we have 4 more. So we're adding on 4 more, which is multiples of 4. All right, now we're going to actually do a problem. So pencils in your hand. It says explain. We're going to do it first. Explain how to use the equation to figure out how many squares Kyle needs if he uses 5 triangles. So if our triangle number is 5, how do I write my equation filling in my 5? I have 2 hands. I'd like to see like 12 hands. So I'll repeat my question. We just did this on the other page so many times. We want to figure out how many squares there will be if he has 5 triangles. So what do we do when we know there's 5 triangles? What do I write for my equation? Quentin?
You want to write, there are 5,
So remember, here's our equation. I wrote it real big for you. So if I know my T for triangles is 5, what do I fill in for my T?
for the T you're going to fill it in with, you're going to fill T in for 4.
Not 4. They wanted to know for 5. So if I have 5 triangles, literally all I have to do is say my square amount will equal 4 times however many triangles, which they said 5. So write that first. Which I think we all know 4 times 5 is 20. So if you want to go ahead and make an equal sign, write 20, that's fine. So we can just explain it very simply. We can fill in T with the number of triangles we have and solve to figure out how many squares. If you have your own words you'd like to use, that's fine, or you can borrow some of mine. We filled the T in with 5 then we could solve for S, the number of squares. Give you a couple more moments. Number 19 we've actually already kind of done on the previous page, so we'll just write our answers here. But it's asking us how many squares does Kyle need if he uses 6 triangles and 7 triangles? And fill it in. We already did that. So I'm just going to say 6 triangles equals, how many squares were in 6 triangles in the pattern?
4.
Well,
Oh, it would be 24.
24. That was on your table on the previous page. So 6 triangles would have 24 squares. Okay, we already did this part, Angie. You have to look at the previous page at the table. But if we were going to resolve it all again, we just did this, so don't get confused. We already did this once. 6 triangles, all I would say, I'd write my formula. S equals 4 times T. He says, well, I have 6 triangles. So I say, okay, my T is a 6. And then I solve it. So S would be 24. And then they said, all right, but what about 7 triangles? So then we redo this. Instead of a 6, we use a 7, which is 28. But we had already done all of that. We already filled out our table, right? We filled out the whole table. So 6 triangles is 24 squares. 7 triangles is 28 squares. All right, number 20. Explain why the equation describes the rule for Kyle's pattern. Okay, finish up quickly. We've got to move on. Explain why the equation describes the rule for Kyle's pattern. Everyone think about that a minute. You guys are good at writing your rules. We've just never done it with an equation. Shai, what do you think?
Basically up by 4, because it's the multiples of 4 basically, and that's counting, which basically is the pattern. So
Okay,
I think it's
so
up by 4.
for every new triangle, we move up by 4 squares, right? For each triangle, we add 4 squares.
What do you mean by that in that sentence? Like, what does that sentence mean?
So you look at the picture while I speak to you. The picture on the first page with the triangles and the squares. For each triangle, we add 4 squares. Do you see how that makes sense? Every time I draw a new triangle, I have to add on 4 more squares, right? Okay. All right, I'm going to pause you guys while I erase and scroll down. Okay. We're down at the bottom at the try it. Use what you just learned about equations with 2 variables. Remember, a variable is just the letter we fill in, right? So we had 2 variables to solve these problems. Okay. Number 21. Does anyone want to read that about Rita? Go for it, Hayden.
Rita wants 2 cupcakes for each guest, plus 4 extra cupcakes. The equation C equals 2 times G plus 4 describes the relationship between total number of cupcakes C and the number of guests. G, how many cupcakes will Rita need for 5, 6, and 7 guests?
Okay. So, no panicking allowed. First thing, we just need to make sense of it all. Okay, well this is important just to wrap our head around. She wants 2 cupcakes for each guest plus 4 extras. What does that mean? She wants 4 extras, because that helps me make more sense of this. Abby?
I think what she means by 4 extras, it's like she has 4 extra cupcakes left over from the people that didn't take any. Like,
Okay, good. So sometimes if you throw a party or something, you don't want to have just the right amount of food, because what if something happens? What if someone's carrying their plate of their cupcake to their seat and it flies on the floor? Well, you don't want to say, sorry, that was your only cupcake. You could say, oh, I have some extras. So those 4 extras, it really is just 4 extras she always wants to have on hand. So the equation, I want everyone to find a space. We don't have a lot of room. Why don't you grab out your whiteboards so you have enough room to write this down? So I'm going to pause you guys and we will be ready. Okay. So friends at home, if you are also out of space, you could use your whiteboard. But we are going to write this down somewhere on a piece of paper or a whiteboard. We're going to make sense out of this equation. Okay, based on the part that was given to us, look through, be detectives. What does the large C represent in our problem? Angie? Cupcakes. C is the total number of cupcakes. So just for now, I'm going to write that under here so I don't get mixed up. C is cupcakes. All right, so cupcakes is C. All right, what's that big G? Emma?
Guess.
My guests. How many guests I have. So I'm going to say number of guests. All right, and the 2 and the 4, well, we can make sense of that too. How many cupcakes did Rita want to give all of her guests? How many do they get, Hayden?
They get at least 1 cupcake.
Oh, our problem is very specific. Angie?
4?
No. Abby?
2.
2. Rita wants 2 cupcakes for each guest, plus the 4 extra. So now, here's how we make sense of it. Every guest that comes gets 2 cupcakes. So this part makes sense, right? If I have 1 guest, they get 2 cupcakes, they'd have 2. If I had 2 guests times 2, I'd have 4 cupcakes. So every guest gets 2. What's this extra plus 4 business hanging out at the end? Abby?
Extra cupcakes.
Oh, she wanted those 4 extras just to have. So that is how this will work. So the number of guests that we have, as it keeps going up, we're going to need more cupcakes. Our total cupcake number will go up. So she wants to know how many cupcakes we will need for 5 guests, 6 guests, and 7. And we're going to fill out that chart over. Wait. That chart doesn't even have the ones we need. So don't worry about that chart. We'll just squeeze it in down here. So you can write 5 equals 6 equals 7 equals. Squeeze it in there somewhere.
Words are on our paper.
On your paper. You could squeeze it around the sides. All right. So I am going to erase this stuff at the bottom so I can show you how to refill this in. When I'm going to solve for 5 guests, I know my G is a 5. So that's my first step. I'm going to change my G into a 5. This doesn't change. Do I know my total number of cupcakes, or is that what I'm solving?
That's what you're
That's
solving.
what I'm solving. So I leave that a C. So now I solve my problem and I know how many cupcakes I need for 5 guests. Does anyone remember, do I have to do my multiplication first or my addition part first? Noah?
The multiplication, because you did the things on it.
All right, so we did multiplication, division, addition, subtraction, MDOS. There's another little part. When you get older, I wasn't going to tell you, but since we're starting to see a lot of parentheses, I'm going to tell you. Hold on.
What does it on our test?
Okay.
Headmas?
PEDMOS. It's a funny word. Okay? When you go all the way through school, you'll use this in high school. You'll use this in college. It will never go away. The P is for parentheses. The E is for exponents, which we haven't really used yet, so don't worry about those at all.
What are those?
Don't worry about those at all. D is division, multiplication, add, subtract. So for you all, just know you do your multiplication and division before adding and subtracting. But do we have parentheses in this problem?
Yeah.
That always goes first.
What are parentheses?
Parentheses are these guys. Okay? So whenever you've got parentheses, the directions in math say do that first. Right away, do it first. So what is 2 times 5? Angie? 10. So now I've got 10 plus 4 equals my cupcake. What is 10 plus 4? Noah?
14.
14. So if I have 5 guests, I will need 14 cupcakes. All right, what if I change this 5 to a 6, right? That's our next step to see if we have 6 guests. What is 2 times 6? Abby?
12.
12. And then I have to add on my 4 more. So we think 12 plus 4 more. Josiah?
16.
16. Nice job. We only have 1 more to solve.
I know.
Okay, this time, instead of 5 or a 6, what number do I need to fill in for G? Hayden?
Or 7.
7. So now I have 7 guests. They all get 2 cupcakes. So that'd be 14. Plus, I need that 4 extra. 14 plus 4, Noah? 18. All right. So, I know that's new stuff, kind of hard stuff, but I think more of you got that than you thought you would. We're going to keep practicing after special, okay? All right, friends at home, thank you for joining. We will keep practicing tomorrow.